Hello and welcome everyone to another edition of PureLine's Food Safety Webinars. Today's topic will focus on the evolution of food safety and advancements in food plant construction. PureLine is proud to sponsor a great panel today. Before I introduce them, I'd like to talk a little bit about PureLine. PureLine is a 30-year-old chlorine dioxide company that specializes in the generation and application of chlorine dioxide. PureLine offers both gaseous and aqueous treatment solutions. The purpose of chlorine dioxide treatments is to reset the environment, whether post-construction or remedial. PureLine guarantees a 6-log kill on all of its CO2 gas treatments. If you or your facility is interested in learning more about a chlorine dioxide treatment or a site visit, please contact me. My contact information will be presented at the end of the slides. We have three main topics of discussion in today's webinar: the evolution of food safety, build by design, and innovations in food plant construction. At the end of our topics, we will have a bit of time for some Q&A for our panelists. In the event we run out of time for our panelists will be glad to connect with you individually to answer any questions you have offline. With this, I'd like to turn the floor over to Nathan to share about the evolution of food safety.
Thanks, Jared. All right. Well, good morning or afternoon, everybody. My name again is Nathan Mirdamadi. I'm with Commercial Food Sanitation. For those of you that are not aware, Commercial Food Sanitation is of a group of over 30 specialists that, on average, have about 20 years of experience working in the food industry, working in sanitation, working in different areas of quality. We all have different areas of expertise or specialties. And then what we kind of pride ourselves on is developing durable and practical solutions to food safety, hygienic design, and sanitation challenges. We do a lot of training. We have 5 different global training centers. And we do trainings, there's a training occurring somewhere on the planet at one of our locations almost every week. So with that, I will go ahead and get into, and I would kind of preface this material saying, the discussion, or what I hope to get from this, is more of just a thought-provoking presentation than more of a technical presentation. So kind of some of the objectives I want to go is kind of a new and a refreshed knowledge on food safety history that I think it'll be eye-opening to some people, or maybe some people just haven't kind of put the pieces together and realized it in the past. Understand the importance of leadership in food safety, and then finally the critical part that strategic investment in hygienic design can make. So with that, it's always great to start out with something beautiful. I'm an old classic Mustang guy, so I think for better or worse, we have to accept that things change. So point in fact is the car industry. I don't think you have to be a car aficionado to kind of appreciate the change that has happened in the auto industry. Since this vehicle was made, or even you look at what's happening right now with electric vehicles, to understand how dynamic the change has been. So if you think about the change that has occurred in the food industry, and I know that you could look at almost every industry and probably over the past 50 years or less see similar evolutions and change. But I think the auto industry, just like the food industry, the changes have been pretty dramatic, and the auto industry just happens to be one that I think people can easily relate with. So now if we think about what the definition of evolution is, it's the gradual development of something, especially from a simple to a more complex form. So, with this, classic Mustang in mind, I'm sure that it's still beautiful to many, including myself. And if you drove it today, it would be just as exhilarating as it was driving it when it was new back in the late 60s. But it has a difficult time, or it's almost impossible to compete with newer technologies, right? So it doesn't matter what you do. It's just Now, as much as you may love the look of the vehicle, it's just not going to be as comfortable. It's not going to be as safe. And it's just going to have a difficult time competing against, say a new Volvo or a new Mercedes. So, if you had, the means and had, a crazy idea that, maybe your 16-year-old son was going to be given, a classic muscle car like this, I'm sure that you'd probably go through and kind of wonder about, are there upgrades or changes that you could make to it to improve the safety of it, right? So, on these old cars, there wasn't power steering. There wasn't disc brakes. There wasn't airbags. So, airbags probably being impossible to go back and retrofit into a vehicle like this. But those other things, you could definitely make changes to it to improve the safety. Now, our food processing plants are similar in some regards to these old classics, or we put a lot of effort, we put a lot of blood, sweat, and tear into our jobs. And I think if we think about it, there's similar precautions that we can use with modern technologies to upgrade or to make changes to them. But the question is why? So, the times have changed, and I'll go into that just a little bit further. So, without a doubt, times have changed, right? And sometimes, honestly, it's for the better. So if we think about our facilities, and maybe some of our facilities look more like the old classic Ford Pinto, but sometimes the classics, or we like to refer to them, almost lovingly as legacy equipment is sometimes the expression used. This legacy equipment, it can be very problematic to manage. So if you're not familiar with the Ford Pinto, it was a very popular model in the mid-'70s. And unfortunately, it kind of got associated with some fires that would break out if the vehicle was rear-ended. Maybe some poor engineering. Maybe it was there's kind of a debate, about if it was actually how big of a risk it was. But needless to say, just the association or the reputation that it developed really was the end of it. So the question is in some of our plants, we may have kind of like these pieces of equipment that are more like the Ford Pintos, right? And we can go through and look at them and say, similar to that Mustang analogy, but can we make changes to them and get them so that they're good enough, right? So we can probably make some changes that will make it better, they'll make it safer, maybe even more economic. But the question at the end of the day is, can we make it so that it's good enough to produce and to be safe for our consumers? So now, with that said, we know, kind of like I said with the Mustang, that there's a point, and might very arguably, or very might well be the case with the case of a Pinto, but if there's inherent engineering challenges, can we retrofit it to a point that we would be willing to accept that risk? So, like I said, if you knew that there was a possibility or a higher risk of a fire if the vehicle was rear-ended, how much reinforcement would you want to do to that rear end before you gave it to your 16-year-old? I would probably argue that there probably wouldn't be enough reinforcing that you could do, right? So I think there's also kind of like this line in the sand that we have to understand or acknowledge that retrofits are possible. We can optimize and we can improve design by going through and retrofitting and modernizing equipment. But sometimes there are kind of these lines in the sand or points where, investment in this is just not practical. So, coming back to the food industry, if you haven't heard about all the discussion about, the era of smarter food safety, or all the increased discussion about food safety culture, or heard about the increasing role that the Department of Justice has played in the food industry, I really would recommend you take a little bit of time and look into it, because I think it all makes kind of this argument for, or the discussion points for the evolution that we're going to be talking about. So as we think about history and food safety, I'm going to, kind of go back, and everybody likes a little bit of a good war story. So I'll start there. So I'm going to make a little bit of a plug for this book that I read. It's called Death in a Pot. And it's a very interesting read. Some of you might enjoy reading it, but you can pick it up on Amazon or whatever. And it actually, the author goes back and looks at different major events in human history and looks at the facts that we know, and then kind of makes the argument that it might have been some sort of food-related illness or outbreak or disease that actually was impacting the direction of history. So it's pretty interesting. For example, the plague of Athens, which was in around 400 BC, it's whenever the Spartans were chasing the Athenians, and the plague of Athens kind of broke out, and it kind of led to the eventual downfall of Athens. And what it's been kind of proposed is that that it was some poor grains that were caused and that had to be eaten because of kind of the Spartans had kind of made it impossible for the Athenians to get to some of their food sources. So the Athenians ended up eating cereals that had went bad and actually devastated their population. But we can move a little bit more recent, and maybe even finally into the 20th century, and just understand kind of how food safety has changed. So if we go back and we think about this book, if anybody is not familiar with a book called The Jungle, which was by Upton Sinclair, written in the early 1900s. So Upton Sinclair was a journalist. He went into the meatpacking plants inside of Chicago with kind of the intent of writing a book that would look at the social injustice and the treatment of immigrants that were coming to the United States and in some of these working conditions. But when he went into these meatpacking plants, what he actually found was some really horrific practices when it came to sanitation and food safety. And this book alone was very instrumental in the development of a lot of the food regulations, the FDA, the USDA, that we have in place today. Now, you may be thinking, okay, so that was 100 years ago. So how is it? Tell me about something more recent, Nathan. So I'm going to take just a kind of a journey down the past, say 30, 40 years, and we'll see and make sure that everybody understands how much food safety has changed just, within my lifetime. So you think about, a very easy one to consider is, the invention of HACCP. So the invention of HACCP coming, with the development of NASA and trying to get somebody to the moon, and really is the foundation for almost all food safety plans today. So we can go a little bit more recent. We think about listeria. Consider that listeria is one of the most concerning and most deadly pathogens that is found in food. It really wasn't even associated with foodborne outbreaks until the early 1980s, when there was some soft cheese illnesses outbreaks in Southern California. There was a really large hot dog recall that occurred that really put it on the map for regulators and for the food industry. But again, if we think about how much the food industry today focuses on and is concerned with listeria, and it's something that we've only really been even known about it since the 1980s. So kind of moving on, so we'll go to the late 1980s and the development of ATP. I'm sure that almost everybody on this call knows about ATP. It's the use of adenosine triphosphate to kind of assess or to verify that sanitation practices were good. It's almost universally used. Some of that through some of the GFSI platforms, some of it being just a good practice. But again, this is a technology that up until the late 80s, and I would say the adoption, depending on which segment of the food industry you're on, could be quite a bit later. But something that is so universal, but again, within the past 30, 35 years has been developed. So we can move forward a little bit more. And some of this is because of our knowledge of listeria, but in the late 80s, early 90s, the use of pathogen environmental monitoring programs started. So and some of this is probably because of listeria. I mean, because we We kind of started to understand that the pathogens would find niches in the environment, and that was how we'd find contamination in our products. But again, the late 80s, early 90s, and what portion or what percentage of, a quality or FSQA manager's time is spent, worrying about, Listeria, ATP results, PEM results, things like that. So, and I can even think back, if you think about when this practice was very new, and I even get this look sometimes today, whenever I go into food plants, you see, somebody will see you swabbing the floor or swabbing the drain. If you can think back 30 years, what do you think the employees were thinking? It's pretty amazing just how far we've come. Now we can move a little bit further, and look at the development of PFGE. So PFGE has been an instrumental tool in identifying the potential root causes and kind of tying illnesses with outbreaks. But again, wasn't even really discovered until the late 1980s. So maybe the 80s and 90s were just really, there was just a crazy time period for food safety. The advancements were just one after another, and hopefully things slowed down in the following decades, right? Well, unfortunately, no. I guess unfortunately, depends on your perspective. But the 2000s brought us allergen regulation, right? So 2004, we had the Food Allergen Label Consumer Protection Act. So and allergens today are the cause for the number one cause in the U.S. for recalls. And again, I remember when I came into the food industry, I would give the story of I used to run a cookie machine back when I was in college, and we would change over. We would almost always go from a chocolate chip cookie to a peanut butter chocolate chip cookie. But on the rare occasion for order, supply, whatever, we would need to run those in reverse. I remember we would wash down the mixer, wash down the chute and everything. We tried to take those precautions, but it was not unheard of to see a peanut come out in the chocolate chip cookies. Now, granted, this was 30-ish years ago. And if that happened at that time, typically what the operator would do is, either take that one peanut they saw and throw that cookie maybe down in the oven band or maybe even eat it. But, fast forward to 2023, the reaction is going to be, shut down the line. We're going to probably destroy product, and rightfully so, right? But it's just how different this evolution has continued to impact the food industry. So, we've also seen in the past, 10 years, definitely the use and advancement of whole genome sequencing. So this technology is going and being able to find the base pairs of the DNA of the pathogens that we have in the environment. And its impact has been profound. And I don't think we've truly understand or we've truly seen the way that, and I'll talk a little bit more about that, but how that's going to continue to change the industry. So you're saying, okay, I get it. Things have changed. But why is that so important? Well, every presentation is much more effective if we're able to kind of pull at your heartstrings a little bit. And I'd like to kind of bring it all back and make sure that we all realize and appreciate that the cute little kids, the loving grandparents, that's who's going to be consuming our products. That's our responsibility. And we, if you would take just a second and look at the screen of your cell phone. It's a practice, or kind of an activity we do at a lot of our trainings. And the people that are on the phone of the screen of your phone, if you could imagine, kind of the outrage, the hurt that would occur, how defensive you are of those people. Everybody has those people in our lives, and we have to make sure that we are treating and thinking about our consumers the same way, with the same intent that we have for those people that are on our computer screens. So, and I'd also say that, the products that we make are very unique when it comes to, consumer products. There's not a lot of other products where our consumer is actually going to ingest the product, right? We have a very intimate relationship. The amount of trust that is needed between a manufacturer and a consumer for that reason is critical. So the question really becomes is, how good do I need to be, right? So we know that, and you've heard me say that things have dramatically changed. The tools that we've developed are much better to not only detect, but to find the illnesses. But unfortunately, the challenge is that a lot of the equipment that we're using was definitely developed far before a lot of these techniques were developed, right? So if we think about, and a point that I want to make sure that everybody gets is the impact that asset life has on all this equation, right? So whoever bought, say, that mixer in the picture to the right, I mean, at the time that it was manufactured, it was probably state of the art, right? But using that same piece of equipment to manufacture food under today's standards would probably not cut it, right? So we think about asset life, we think about the purchases that facilities are making. Those assets are going to far outweigh the life or the kind of the current era that a food regulation that they're seeing. So, if you purchase a piece of equipment, you have to also understand not only what the design expectations are for today, but you really have to understand where they're headed because of the life expectancy and just the way things. I mean, I think everybody can just appreciate that the bar is only going to get more and more difficult as we proceed. So, the next, if we think about, why things have changed and why that's so important, just a few thoughts about Genome Tracker. If people aren't familiar with it, it's a group of 19 labs here in the U.S. federal labs. It's got 40 state health labs included in it. It's also got labs that are associated with it globally, 24 additional labs, and it's a collaboration between regulators and environmental health specialists and scientists and researchers that rely on using whole genome sequencing. And the important thing to note here is that whenever the sequences go into the system, they don't expire, right? They don't just one day, you have a pathogen or a stool sample go in there and one day that information is just lost. It's data and it's going to last forever. And a couple examples to kind of drive a point on that is, there was a serial recall associated to a manufacturer back in the late 90s. So that recall, the company did a lot of work to make sure that they took care of the problem, right? Now they continued using the facility, and 10 years later they had a CapEx project, and they ended up disturbing and unearthed the pathogen that had been kind of buried in their environment. So through some of the construction activities. So they found this dormant pathogen and kind of unearthed it. And they had a similar recall 10 years later. So if you think about how remarkable that is, an organism to survive and then the same strain to cause illness 10 years later. Another example is, just several years ago, we had a very large outbreak associated with ice cream. Ice cream has not been a product that has historically been considered a high risk for listeria because the product is frozen, right? Listeria won't grow when it's frozen. It'll survive, but it won't grow. So, in this case, whenever the FDA and the CDC got involved, they had stool samples from people that had become ill, right? They went and did the sequencing, and this food processor was actually tied to and blamed for illnesses that had occurred 4 years prior. Okay, let's stop and think about that for a second. I always use the example of if you were to get home and got a ticket in the mail for running a stoplight that you did 4 years ago. As a food processor, once this data goes into these systems, there isn't a statute of limitations or a date that suddenly that you're not going to be held responsible if something happens. So it's pretty concerning. So as an industry, as a globe, we've never been able to communicate across the country or the globe as well as we can today about foodborne illnesses. And there have been, through Genome Tracker, there have been recalls and illnesses tied to manufacturers with as few as 2 cases. I mean, 2 illnesses triggering, a recall, which is pretty impressive. So continuing on this question, it kind of goes down to what is good or what is good enough. So, I think, and this is truly the million-dollar question, right? So when we think about the excellence in food manufacturing, kind of what the gold standard is, usually Six Sigma is kind of seen as that pinnacle. And if we think about Six Sigma, so Six Sigma being 3.4 defects per million opportunities. Now, for a food manufacturer, 200 million servings is not unheard of. It's, you think about even, there's a lot of plants that will do 200 million pounds, right? So 200 million servings is definitely very realistic for a food processor. And if we think about how many potential illnesses they could cause if they were achieving a Six Sigma level of defects, they're still looking at 680 possible defects. Now, we think about how the Genome Tracker works and maybe 1 or 2 illnesses. We know a lot of foodborne illnesses are never reported. That's still a lot of risk that goes out there. So, now we can't get in the mentality that, we're not going to be able to get to Six Sigma levels or perfection, even though perfection truly has to be what our goal is. And we really have to make sure that we're working towards it, because there's so much at risk. There's so much that we can do. And the final kind of point is, making sure that we understand that being good enough, and because I've had these conversations of, how good do we need to be? And really, unless you've got a perfect crystal ball, it's very hard to say. We know that things are going to get more challenging. We know that regulators are going to find or make it the sanitary conditions or the expectations more and more. They're going to raise them even higher. So we definitely have to be working to try to at least aim for perfection, knowing that we're going to fall short of it, right? But it's still got to be our goal in the area of food safety. I kind of started the presentation by saying that we were going to be talking about, kind of the evolution of food safety. Now, if you think about, evolution being something that's more gradual and a slower paced change, I would actually submit that we're actually seeing as a revolution in food safety, because, the supply chain or food, consumption of food has been around since man began, right? But if we look at the changes that we've seen, not only through the supply chain itself and the manufacturing of food, but you think about the technologies that we've kind of touched on, and I didn't even mention, things like FSMA that is definitely changing, or even more recently, the FASTER Act, which has had an impact on allergens and sesame. There's no doubt that technology will continue to outpace the industry. So it's very easy to find an organism to tell you what the problem is. It's a whole nother equation or a whole nother set of problems to actually eliminate it. We don't have 100% perfect control of our environments. So as I said, the industry is going to continue to learn, it's going to continue to grow. But kind of keeping with that in mind is if we were sitting 15 years ago and we were going to be consuming products and we say, which product is the most dangerous, right? Out of, some sort of basket. A lot of people would point at the deli meat, right? They would say, oh yeah, it's been associated with outbreaks. It's very dangerous. But, if you think about that, if you ask that same question in the past, 10 or 5 years, I think universally people would say that, fresh produce can be equally dangerous, if not more, because we don't have a very thorough kill step in the production or cleaning of fresh produce. So kind of this revolution is only going to continue. We're going to find more and more pathogens, maybe viruses that are going to be associated with food. The association of acute illnesses that actually occur over time. We're only going to continue to discover things, which is going to make food production more challenging. Now, after all this, I think many are saying, well, maybe we should just surrender now, right? It's basically an impossibility that you've kind of outlined. And I don't think it's an impossibility. I definitely think it's a challenge, right? But I think what I've seen is that, I go into a lot of food manufacturing operations, and if you're going to survive, if you're actually going to thrive in this current environment, it all starts with an honest, continuous improvement mentality when it comes to food safety. A perfect example would be is if you have a pathogen environmental monitoring program, are you swabbing the drains, right? It's so simple, but a lot of plants, even today, will not swab drains because they say, well, Listeria is going to be in the drains. Well, we have to come up with programs to make sure that Listeria doesn't find a way to harbor in the drains, right? Because that harboring is going to make its way into our manufacturing environment. It's going to find a niche, and eventually it could end up in our product. But really, we have to make this conscious decision to go from a reactive mentality to a proactive mentality. And a lot of this is through these programs that can help us reduce risk. I mentioned the pathogen environmental monitoring program, but even if you kind of dig into the weeds on that program, it's not enough that you have a program. But is your program truly challenging your environment? Are you really trying to find the organism? And there's a lot of change that you can make if you understand and really challenge your program. It is not uncommon for us to go into facilities and go through and look at PEM programs and see, I've been in one in just the past month. You go in and you look at their PEM program and they've had one positive in the past 18 months. And we commonly will go into these same sites and take swabs of our own to I always say, it's kind of kick the wheels to see how the PEM program's working. And we can find as many as 12 or 14 presumptives out of 20. So you sit there and you say, well, how much value is that PEM program actually developing or delivering if I'm getting a false sense of security and I'm not finding the organism, right? So we really have to kind of change this mentality of and be proactive in our response, okay? Now, and this is not as much of my final one here is not as much of a position, but more of a comment. I just love it every time. The first time I heard it, I try to reuse it as much as I can, so I just threw it in here. But, you think about, back when Edison was developing electricity and developed the light bulb, there were still people that were working consciously on trying to develop better candles, right? Maybe playing with different waxes and different stems or fuse or wicks, but we didn't need better candles. What we actually needed was the light bulb, right? So sometimes we have to take a step back and stop trying to invent better candles and try to make actually a revolutionary step change in technology and see, is there another way to do this that is going to be even far more effective and really challenge the status quo. Now, with every single change, whether it's a regulatory or it's a technology change, there's definitely winners and losers. So the way that we succeed as food processors is that we find ways to leverage this change and leverage it to our advantage, right? There are going to be opportunities to be winners in this change, right? There are going to be processes that are able to, they're not going to survive with these new expectations. So what we really have to be doing is looking at ways to leverage these opportunities for our businesses. So really then the question becomes is how do we adopt? Are we creating facilities and building facilities that can do it best? So and making sure that we're not building ourselves or painting ourselves into a corner. And then finally, I would say is that we have to make sure that we're really challenging ourselves. A lot of times facilities go through regulatory audits or inspections and audits. And I just want to make sure that everybody realizes that the way that I look at audits and regulatory visits, this is kind of like the ticket to entry, right? This is the minimum expectations for being in food processing. And really, if you want to move the bar forward, if you want to minimize risk to your facility, you have to be comparing yourself to the best, right? You have to benchmark against the best. It's not good enough that you're better than average, right? Or even if your goal is to be average. I would say that the goal of audits basically is to survive, right? But we really have to be comparing ourselves against the best in order to thrive and to move the ball forward so that we're not caught behind. So kind of wrapping up in summary, the past 30 to 40 years has seen dramatic change in food safety, it's not going to change. There's no indication that it's going to slow down, right? So we really have to be thought leaders, develop and understand where these changes are occurring, what's on the horizon to really help our businesses. And then these technology advancements are only going to continue to revolutionize food processing as we know it. So with that, thank you very much for your time and attention, and I am going to pass it back over to Jared.
Thanks, Nathan. That was great. Thanks for providing such an in-depth review on the evolution of food safety, which transitions nicely into our next topic that Agustin will cover, which is food plant design. Agustin, the floor is all yours.
Thank you very much, Jared and Nathan. I think it was a really good snapshot in history on how things have evolved and how we can prepare to in the future to develop to implement new technology and definitely roll up new designs. Somehow my slides are rolling up a little bit slow, so bear with me. Once again, I'm Agustin Salas. I'm an integration manager at Gray AE, Architects and Engineers. So just hang on a little bit. Alex, my slides are not turning. Can you hear me, Alex?
Yes, I got you.
Thank you. So yeah, please give me a hand here. Somehow my bandwidth is giving me challenges. If you can just pass them over once I'm done, I'll let you know. Thank you. So yeah, going back to the topic, definitely a great snapshot in history. One of the common elements here is safety. Traditionally, safety can be adapted to just about anything. The previous slides that we just saw are good examples of safety risk. These safety risks basically across the industry can be reflected in many different ways. The way we do it at Gray is around this schematic picture that I'm showing right now. And basically what we want to pass on here is that we always need to stop and think what we're doing and then react. Part of that evolution in the industry is that we have passed on that safety culture in the way we do things on a regular basis. It doesn't matter if we're building a plant or if we're designing one. We have building that into our DNA and basically stop, think, and then react. Safety can play into good and bad designs, as seen here. When things are designed in a manner where they cannot be properly cleaned, can result in a significant food safety risk. I can bet you a lot of these instances went as a result of go fever. And planning could also be part of the root cause of it. So I want to cover a few things that might be relatable to your role, Nathan, and to the audience. Go fever is basically based on time and schedule. It definitely has changed in the industry these days. It's not about beating a deadline. It's not about beating the schedule. It's about doing things safely. Because things can happen in the blink of an eye. Rush calculations can lead to errors. And definitely that's something that you don't want to have in a situation where you are involved, call it a project, a design, or during construction. I have seen a shift in food safe construction because multidisciplinary teams are thinking about contractors, operators, sanitation staff, maintenance, and the food safe longevity of materials. We recognize that accountability is ours. If we see it, we own it, and if we pass it, we condone it. Alex, can we move to the next slide? So what's different out there in the design world in these days? We definitely we build by design. We are extension of the customer. We definitely want to get involved in the customer needs. We want to hear those needs, and we want to put those needs into a design and then build a solution. Maybe not the why whys or 7 whys, but several whats. What does the customer need? It's really important. What's limiting the customer today, and what are we designing towards? And maybe also a couple of hows. The right sizing projects for long-term success, and engineer for maximum customization and design around growth. What are we doing to bring food safety to our design? We definitely become partners and not just service providers. Go ahead, Troy.
Yeah, one big thing that we're seeing in the change within our industry is the prevalence of hygienic design. So with the adoption of J1 and J2 by EHEDGE and 3A, we are seeing these hygienic benchmarks, being applied within industry, actually directing equipment manufacturers on how sanitary equipment needs to be built. Components, we're seeing these components having these standards applied to them and interpreted. Utility systems, we've got utility providers that are creating sanitary systems that, like Rocket Rack or CleanFab, that can actually, be cleaned, have your utilities within the spaces. And then for your operators, we've got options within the facility to help clean that facility through the appropriate selection of utensils that work for cleaning this equipment, as well as can be detected if there is a failure.
So definitely one of the key components in evolution, designing new plans, is larger multitask and disciplinary teams. These will create repeatable food safety results based on trained employees to have the right environment to validate and verify their processes. This will be sustained by having GMPs, sanitary equipment design, a sanitary design facility, and knowledge on hazard. All of this supported by a continuous improvement process, which all of our key stakeholders will be related in all these components. So successful projects engage multiple disciplinary teams from beginning to end. And there's also different construction delivery methods, such as design build, design bid build, construction manager at risk, and integrated delivery. Contractor awareness of hygienic construction practices is very important. Hygienic construction practices ensure that workers and construction activities do not create a food safety risk during or after construction. The site team will review facility constructions to define the plan and implement hygienic construction practices appropriate to the activities and phases of the project. Nowadays, subcontractors will be briefed on hygienic construction practices as part of the safety orientation before being allowed on site. That's definitely a given if you want to pass on that message into the trades that are involved in building a facility and prepare yourself into a starter point. So yeah, definitely everything starts with chaos. There's no shape, there's no form, but definitely we are here to put some shape in what we do. So today, what we can offer is a nice transition of product, segregating areas, separating the cook from the chill areas, and provide a good flow that promotes sanitation. Definitely people, product, and waste are key components of a clean flow that will promote sanitation.
So some of the innovation that we are implementing into the design and construction process of food plants of the future are, just continuing to embrace the 3D technology that we use to design. So in this instance, red is materials that have not been installed yet, green are materials that are installed, and yellow is materials that are on site. So through the use of on-site inspections, surveys, technology from the office, we can track what's being installed, what's not installed, schedule site visits, coordinate, other trades that are going to be working in this very congested area, all with the hopes of reducing errors and, decreasing the cost of building, these facilities or installing this equipment. Because the problem is, as we run into these clashes, as we run into these problem areas that we haven't thought through, we get back to that go fever and we start to make decisions in a vacuum. We don't have the appropriate stakeholders engaged at resolving this clash. And then we create an uncleanable situation that just leads to a lifelong trouble for operators and maintenance staff. We are trying to utilize technology to train operators, bring maintenance staff up to speed, and get sanitation's input on these facilities when it's just lines on paper before we actually get to construction. So these are lifelike models that we are using to get stakeholder engagement, make sure we've designed the facility in a safe for operators, but then also for sanitation and maintenance. Really understanding where we're going to put humans, where's the scissor lift going to go, how is this filter going to be replaced, and providing all the mechanisms necessary for that to be done successfully. Also, benefit of this realistic modeling is we can do on-the-job training through a computer. So before a human has their first day out on the floor operating this equipment, we can put them in a virtual environment, simulate some failures, talk to them about how material is going to get into this location, with all the hopes of, keeping them safe and keeping the folks on your phone safe, so that we're manufacturing in a safe way. Some new things and exciting things is we're using robots to really dig in, take humans out of dangerous situations and send a robot out there. So if a picture is worth 1,000 words, a video might be worth 1,000,000 words, and a camera on the back of a robot walking around the site might be indispensable. So we can deploy that robot, get on-site inspections, get stakeholder engagement from that. Many of you have seen, time-lapse photography of construction being built around your homes, and that's awesome. Could we do that from the inside of the facility so that we can bring QA up to speed as we're building this, or communicate to other trade partners when is the room going to be ready for their utilities to come in, or when is it too early for them to deploy to the site? Part of our technology growth is, having computers, having laptops, having telephones that can do this. So here, we have an example of, this robot going through, taking pictures. You can pull this up on your phone from anywhere. So whether you're on site or on vacation, you can get eyes on, that detail. So here's an example. On the left is the modeled environment, and on the right is the current construction. So here we had a lot of concerns about where that bridge crane was going to be running. Are we going to have clearance issues? When are trades going to be in these areas? And so we were using the model to determine when we needed to have certain trades, when certain foundation systems needed to go in, and it was a great success. This isn't really novel, but it's that collaborative approach where we're getting all the team members engaged and showing that progress.
Definitely, robots are here to stay. I think this is the year where I have seen more presence of robots, not just out in the field, but out in the market as well. Call it effectiveness in operations, or just the situation right after the pandemic. Not just to help with ergonomics, but definitely with the space and repetitive motion and stress on the workers. Robots definitely are not just on the dry areas anymore. The more we advance on technology, the closer we're getting into the food contact areas, food contact zones, where the tooling of the robot will be at the mercy of the elements of the food, and it will be at the mercy of the sanitation processes as well. Next slide.
So we talked a lot about the evolution of cars at the beginning of the presentation, and now to think about the evolution of buildings and manufacturing processes. I hope no one's too grossed out by this, but protein harvesting is a main part of my life and my love. And to think about what we were able to do, 50, 75 years ago, when the jungle was published, to now where we have these bright, shiny spaces that are very cleanable. We can swab drains, and there's a chance we might not find something. And really just what has evolved in these facilities is primarily materials of construction and competitiveness to the marketplace and the availability of these sanitary standards. So we're seeing just an immense growth in this market. We actually see competitors, in all delivering all these systems. We see innovation. We see these applications being applied to new industries. So it may not be a new, drain type or, detail, but it's something that's now being applied to, a different industry to solve maybe a different problem that it was originally designed to handle. So like it or love it, here's some, kind of highlights about, things we are seeing in industry that are really transforming how safely we can operate a facility. Doors, we're seeing a huge growth in really focusing on keeping that outside environment outside of our manufacturing spaces and keeping that inside environment controlled, pest-free, condensation-free. So there's been a lot of evolution within the marketplace about options to keep that the environment that we need to manufacture in. Some other things, reduction of glass. We have glass alternatives. We have technology that can replace windows. So we can integrate cameras into a manufacturing line so we can get eyes on, the speed of something. We can get status readings within the process to output to a job board to tell the team, to tell the plant how effective we are maintaining those manufacturing speeds. We've got a better appreciation for where do those viewing windows need to happen. If touring a guest through your manufacturing facility is critical to the success of your business, maybe we do that to keep those dirty guests out of our manufacturing space and keep them, corralled to a safe place. Keep your food safe and keep them safe away from, all these moving parts. We're seeing a lot of improvements in, the chemistry of materials of construction. So we've got gaskets and seals and sealants that are more able to withstand the sanitation cycles that we are imposing on these facilities. And then, within construction, there's a lot that we can do to reduce those food safety risks. So trying to bring things full circle, Nathan and Jared talked about, things that we can do post-construction to begin to clean the environment. It starts with the employees as well. It can't just rely on chemicals. So we can start to decrease those biological loads that are being transported into a facility by embracing, our customers' GMP process. Simple things, just cleaning vehicles before they come into a facility, respecting those sanitation separations within a facility, making sure certain employees are not crisscrossing. And all of this, comes to particular attention when we've got an existing process. What do those temporary barriers look like? And how do we really help our customers control what they're doing, on the other side of this wall? So what do the future of facilities look like? Who knows? Your guess is as good as ours. But, things that we do to really try to embrace that is, modular construction. really think through what the facility needs to accomplish today, what it needs to accomplish in 5 years, and how is that new technology going to come into this facility physically or technologically. How is it going to fit into this facility? So we have a plan for what we think it could be, and we try to document and communicate that plan through good door sizes, economic dimensions, with controlling what we're investing in that facility today for. So skid systems, modular construction, prefabrication, precast materials are great for maintenance and repairs as well. So these are some of the things that we're seeing in the industry that are really revolutionizing things. So with that, I really want to say thank you to everybody that participated. Jared, I don't know if you want to.
Thank you, Troy and Agustin, for sharing the innovations and advancements and on the food plant construction side. I see that we're a few minutes over the time allotment here. I know a couple of you guys had some questions about whether this recording and presentation would be available. It will be. So Alex will get this prepared and we will email it out to anyone that wants it. So feel free to reach out to myself, Nathan, Troy, Agustin, any of the questions that you guys submitted, whoever the appropriate person would be, whether it's Nathan or someone from Gray, will reach out to you guys directly. So thank you everyone for joining us and have a good rest of your day.
Thanks, everyone.
Thanks, guys.
Thanks.